Good evening, everybody. I hope you're all doing really well. Welcome to my talk about reactive programming. It's called Adopting a Reactive Mindset, and I hope this talk will be a very helpful guide for you to make sense of both combined and functional reactive programming, because it's a topic that I struggled with a lot when I just started doing it, and I really feel like a lot of people are going through the same struggles. So let's take a look at it and see how you can start integrating combine into your projects and your whole mindset. I think most of you already know me. If you don't know me, my name is Donny Wals. I am an iOS engineer at Disney Streaming Services. I am also a blogger and an author. I published a book about combine earlier this year. It's called Practical Combine, and you can buy it at practicalcombine.com. And if you like this talk, if you want to learn more about combine, I can definitely recommend that book. It contains tons of examples, tons of information to help you get started with combine as soon as possible. Now, when I first started learning functional reactive programming, I thought it was a pretty complicated topic. I had looked at a bunch of tutorials, I checked out RX Swift, and I talked to a bunch of people who I thought were really good at functional reactive programming, and they were really good at functional reactive programming. However, it wasn't easy for them to explain functional reactive programming to me. I heard statements like, it's basically just streams, or it's all about values over time. And these statements to me didn't tell me much. They were quite frustrating, to be honest, because if you don't know what functional reactive programming is, telling somebody that something is basically just streams makes it sound a lot easier than it is, because this stuff is actually pretty hard. However, it doesn't have to be that hard. It doesn't have to be super complicated. It doesn't have to be very confusing. It's not easy. Let me say that up front. It's not like you can pick up functional reactive programming in a matter of days and be very proficient in it. However, the core principles that it's built upon and the basic ideas that you need to understand to do functional reactive programming are not rocket science. And I hope that this talk can help you understand that and help you get into that mindset of reactive programming. Now, as you often do with explaining terminology, you can look at the full word and you're going to pick out one of the words that's interesting to look at or to understand. In this case, I want to take a look at the word functional in functional reactive programming. And the word functional actually does not stand on its own. It comes as functional programming, which is probably a term that you have heard before. Now, functional programming is all about several core principles. The first core principle is that instead of programming with objects, you're going to be programming with functions. Now, if you're familiar with UIKit and Swift, you have done tons of programming with objects. It's just your plain old object-oriented programming with classes, subclasses, structs, inheritance, the whole thing. It's all programming with objects. In functional programming, you try to encapsulate all functionality in very lightweight objects, and preferably in functions that contain a lot of the operations and logic that you are going to apply. Now, your functions in functional programming are supposed to be pure. What that means is that your functions should not have any side effects. They should not rely on any state that exists outside of a function, and they should not mutate any state that's not inside of the function. A good example of this, and really a good example of functional programming in general, is Swift's map. Right? You take an array of something, you loop over it essentially, and for every element you execute a closure or a function. And that function only takes an array element as its input, and it's going to produce a new element without modifying the original element. Which brings me to the next point, which is higher order functions. A higher order function in functional programming means a function that takes another function as its input. So map is a very good example of this. It's a function that is applied to every element in an array, or it's a function that is applied to an array, and map takes another function that will be applied to every element in the array. So that's a higher order function. Swift is full of them. Map, flat map, filter, reduce. All of these are all higher order functions that you may have used some point in time. Now, functional programming is also typically very composable, right? You can take a map, produce a new array, and then map over that array again, or you can flat map over it or apply some other operator. The idea in functional programming is that almost every function will be able to compose together very complex flow of functionality through functions and through composition. So that's really all you need to know about functional programming for now. Functional programming, of course, is far more involved than just these 4 bullet points, and it's far more complicated than I could ever capture in these couple of bullet points or really in any talk. However, if you understand this, you understand enough to get with the program of functional reactive programming. So let's look at a very quick example that I'm sure will look familiar to almost everybody here today. You have an array of integers, right? And you call map on it, and you supply a closure to the map, and that will take an integer as its input, and it's going to return a string. And then you can print all these strings, and you'll have your array of strings, which is the result of applying map to an array of integers. It's really quite elegant, quite simple, and quite easy to understand once you are familiar with this paradigm. And this is just normal Swift code. This is not reactive programming at all. Now, more interestingly, you also have something called flat map. Now, if you would take an array of integers, map over it, and return new arrays, right, you would get an array that contains arrays. That makes perfect sense, right? You transform an integer into an array, which means that you're going to get an output of arrays. However, if you use flat map instead of the normal map, you don't get this array of arrays. You get an array that contains integers, and it's a flattened array, right? All the nesting has been removed. So instead of getting an array that contains 0, 1, another array that contains 0, 1, 2, etc., you get 0, 1, 0, 1, 2. This is very useful, and I want you to remember flat map because we're going to see it again later in this talk. Let's move on to the reactive bit, functional reactive programming, because that's where all the fun is at. Now, functional reactive programming, the reactive bit is all about responding to changes, right, or values that are emitted, or things that happen over time. There's that statement again, values over time. I promise you that will be pretty clear by the end of this talk. Now, when you think of these changes, you need to consider that lots of things can be changes. The user tapping buttons can be changes. The user scrolling can be a change. The keyboard appearing can be a change. The user receiving a notification can be a change. A network call completing and giving you its outcome can be a change. Really anything can be a change. Now, sometimes you're only responding to a single change, right? The majority of the changes that I just mentioned, like a user scrolling or tapping something, happen often in an application lifecycle. However, a network call completing will only happen once for every network call. In that case, you are responding to a single change. Now, eventually, these changes might stop. Right? A network call is going to get a result and then tell you the result, and then it's going to tell you that there are no further changes. The call completed, and it's done. So the changes for that will stop. Other things will never stop. For example, notification center notifications in iOS never stop. You will continue receiving those for as long as your application is active. Now, a change can be a value. In fact, in Combine, a change is always emitted as a value. It could be a void value, but you're always going to receive something to tell you that a value was produced or that a change occurred. Now, these changes or values are streamed to the receiver. This means that the receiver simply tells a publisher, which will emit values or changes, that it wants to listen to these values. It wants to receive them. So the publisher will then start sending these values to the receiver, or the subscriber as it's called, as they occur. right? So you don't have to query for them, you don't have to go out and find any new values, you're going to receive them. So they are streamed to you. Let's look at a little bit of reactive programming code, shall we? So here's a pretty basic example that captures pretty much everything that you really need to know, or at least the basics of everything that you really need to know. The first two lines here are not interesting at all. They're just properties that I had to create to make sure that all the code fits on the slide. So we can create a publisher in Combine. So this code is very specific to Combine. You can call notification center publisher for and pass it a notification name. And at that point you have a publisher that will send changes, or in this case notifications, to its subscribers. Now, publisher is a generic object. It takes two generic arguments, so it's strongly typed. An example could be an any publisher, which is a type arrays publisher that you can use to wrap up any kind of publisher and hide its internal type. And you specify what kind of values it will emit. So, for example, cgrect, which is the result of the code that I'm about to show you. And you tell it what kind of failures it might encounter. Now, not all publishers encounter failures, like the one that I'm creating on this slide will never fail, so I supply never as its failure type. If it could fail, I could use a generic Swift error, I could use NS error, or really any kind of value at all. Now, Combine also has operators. For example, it has compact map, which looks very familiar because compact map is also defined on arrays or sets or other kinds of collections in Swift. But this one's different because this one is specific to Combine. However, it functions the same. It's a simple function that takes a publisher's output rather than an array element and transforms it into something else. So in this case, I take a notification and I transform it into an optional cgrect. Now when you return nil from that closure, the value will be omitted. Just like if you would compact map over an array, all nil values would be stripped. If you compact map over a publisher, all nil values will not be forwarded to any subscriber. So in this case, if extracting the cgrect or the keyboard frame fails, it will not result in a nil value being delivered to a subscriber. Okay, and Combine also contains many different operators. But a lot of them will behave like map, where you take an input, transform it, return an output, or like flat map, where you will flatten a sequence of nested publishers. So if you would create a publisher inside of a flat map, then every value emitted by that publisher will be sent to the subscriber, and it will look as if it's a single publisher generating all these values, just like how an array with nested arrays will be flattened into a single array. Okay, so to receive these values, you need to subscribe, and a subscriber in Combine is going to receive values and completion events from publishers. So you pass it a receive completion closure that will either get a success value or a failure value with an associated error that you can extract to see what went wrong. In this case, nothing can and will go wrong. And you pass it a receive value closure, which will receive any values that are produced by the publisher and all of the operators you apply to it. So in this case, that's going to be a keyword frame. Now, errors do not go here because they go to the receive completion. Once a publisher fails or completes successfully, receive value will never be called anymore because the publisher completed. It told you that it's not going to send you any further values. Okay. The last thing to note here is the cancelable. Whenever you subscribe to a publisher in Combine, you are going to receive an any cancelable. And the any cancelable encapsulates the relationship between a publisher and its subscriber. And when this any cancelable is deallocated, the whole subscription is torn down and you will not receive any more events. So this is very important to do whenever you want to receive output from a Combine publisher. Okay, so going back to that initial statements, it's basically just streams and it's about values over time. It suddenly makes a lot more sense, doesn't it? Because now you can see that values are streamed to the subscriber and that these values occur over time. They might take a long time to accumulate, for example, throughout the course of your whole application's lifecycle, or they could all accumulate in seconds or even milliseconds. Okay, so once you get this and once you see how publishers work, you might think to yourself, I'm going to use combine everywhere. So you start with refactoring your network code, and here we see that interesting little any publisher user profile error. That's a type arrays publisher, and we do that to make sure that our API looks neat. Because if I would create a data task publisher, which will simply execute a network call and provide us with an outcome, I will have a publisher called a data task publisher that emits a tuple and has URL error as its failure. Now that's not the type of publisher that we want, because we want to do some things with it. We want to take that output, that tuple, and transform it into a user profile, because that's what this function is supposed to do. So we map over it and we extract the data. Now that would give us a publisher.map key path, which is generic over the data task publisher and outputs data. Now this is already a return type that you wouldn't want to type. That's why you use any publisher, so you can wrap that all up nicely in a typable and readable publisher type. Now once we've extracted the data, we have something that will emit data. And then we can use a decode operator that we only tell what type we want to decode into and which JSON decoder we want to use. And that will then emit only the user profile object in this case. So it's going to take that data as its input, decode it into a user profile, and then output the user profile. And because the return type that I wrote at the bottom of this slide will be what's returned after this publisher or after this operator, we're going to want to erase it to any publisher. So that's a very simple example of a network call and combine. Now consider something more complicated. For example, you have a login call, and when a user logs in successfully, you're going to fetch their profile, fetch their likes, fetch their friends, and then you're going to update your UI only once all three of these calls are completed. Now that is quite some work, and you may have an idea of how you would achieve this with only URL session and maybe a dispatch group. So let's see how we can do it in combine. And to do that, I'm going to add a couple more functions. For example, a login function that I'm sure if you scan the code real quick, looks pretty predictable. And I've also changed the get user profile function that I showed you earlier to take an access token, right? Because we need to make everything authenticated. How we authenticate is pretty much irrelevant, because that would work the exact same way that you would configure a URL request if you would only use URL session without combine. This login function will be the first function we call. It produces the access token, so the get user profile function will rely on the output of login, just like we mapped out in the previous slide. Now I've added a bunch of other functions with very predictable return types. So this is pretty understandable, I think, and pretty basic in terms of what the functions are supposed to do. So we might write some code, instantiate login process, and take a completion handler, which is, of course, not what we want to do. We want to return an any publisher because we're working with combine, but I'm not quite sure what the types would be here yet. So let's just try something. Let's just initiate the login process, return an any publisher that returns that emits a Boolean value that simply tells us if the login was successful or not, and a failure type, which is just a generic error. Okay. First note that I have is set here for my cancellables. I can store them. I can store any cancellables produced by subscriptions using the store in operator, which is a very convenient operator. The initiate login process function creates a future. A future in combine is a special kind of publisher that will execute its work immediately and publish its outcome as if it were a publisher. So you can use this to wrap up pretty much any asynchronous work, which in a first attempt might sound very tempting if you want to create a login flow like the one I just showed you. Okay, so next we call the login function, we subscribe to its outcome, and we set an access token when we receive a value, and then when the network call tells that it's completed, we check if there's a failure. If there is, we're going to forward that. We're going to emit a failure from our future. And if it all worked fine, we are going to kick off the get user profile and all the other functions. Now, this code is basically imperative, right? I went over it very quickly because it's just not that good. It's not what we want to write when we do combine. So even though I promise you that this stuff didn't have to be very hard, it's still pretty darn hard. But it's absolutely essential to understand the building blocks. So let's go back to that initial statement. It's basically just streams. And what that means is we're going to want to start with a value. In this case, the login call and then the access token that's emitted by it. And then build a pipeline of transformations on top of it to get where we want to go, which is the result of these 3 network calls. So this right here, that's not great. That's not what we want to do. Now remember the flat map that I showed you earlier that did this? You have a bunch of values in an array, you create new arrays, and if you flat map it, it's going to be a flat array of values. I already mentioned that you can do this with a publisher in Combine. So if you have a publisher, you flat map over it, all values emitted by these nested publishers are going to be emitted to subscribers as if it's a single value. Now that's something important to keep in mind. Now, what we can do to do the first little steps is call networking.login here, which will emit an access token. If we flat map over that and return the publisher created by getUserProfile, then our sync right here, our subscriber, is going to receive that profile, right? The result of getUserProfile. But that's not quite what we wanted, because we wanted to do 3 network calls and then update the UI. So how do we do that? Well, it's actually not that hard in Combine, which makes it very, very interesting. Because in the previous slide, you already saw that if you return that getUserProfile publisher from the flat map, then you get that as an output. Luckily in Combine, we can also merge publishers into one. We can combine their results. So in this case, I create 3 publishers. getUserProfile, fetch likes, and fetch friends. All 3 of them produce a publisher. And I can combine those into a single publisher because I cannot return an array of publishers from my flat map. Let's make that very clear. I have to return a single publisher from the flat map because otherwise this is not going to do what I want. And because I want these 3 calls to run in parallel, I can also not stack 3 flat maps. So by using combine latest on my profile publisher and adding the likes and friends publishers to it, and I'm erasing it to any publisher because I can then have a very nice return type, I now have a single publisher. And what's very cool about combine latest is that it emits a tuple of all values that were emitted by the publishers that it combines. So in this case, we're going to get a tuple of user profile, an array of liked items, and an array of friend info. And as soon as that's emitted, we know that all 3 publishers completed successfully, and we can use our result. Now, once you understand this, it's easy to say use combine everywhere, because now you understand the basic building blocks. You understand what combine's all about. You understand what's meant when somebody tells you it's just streams. You take a value and you build a pipeline that takes that value in and transforms it and molds it into something that you want to use. Now, the example that I just showed you is not a trivial example. It's not something that I would expect any beginner to be able to do, but it does show you the power of flat map in Combine. So let's summarize this talk a little bit. Functional reactive programming is built on functional programming principles. It's all about responding to changes over time. Combine uses publishers to send values to its subscribers. You can transform values into other new values or even transform them into publishers. And lastly, understanding Combine's core building blocks will help you to use Combine in an effective manner. When you know how to flat map and when to flat map over a value to produce new publishers and how to combine publishers into a single new publisher, that's when you can start using Combine optimally. So I would definitely recommend that you focus on learning building blocks of Combine rather than recipes, or rather than diving in and writing imperative code within your subscriptions. Thank you for listening to this talk. And if you liked what you heard today and if you want to learn more about it, make sure to check out my Practical Combine book. It goes in depth on all this stuff and much, much more. Thanks again, and have a nice rest of your day. So, I hope you all enjoyed that talk. I see a couple of questions in the chat, so let's go over them. If you have any questions while I am answering these, the ones that I already see, or if you want to know more based on what I've said, then feel free to ask any questions you have. So the first question is one that I see all the time, which is why is erase to any publisher necessary? Isn't it nicer to have a typed publisher? And actually, I see that Paul in the chat gives pretty much the answer that I would give, which is that if you don't erase to any publisher, you would have something like I showed in the beginning when I showed you the first little bit of reactive code, something like map publisher generic over map keypath, generic over flat map, generic over this, generic over notifications, and it emits this or that, which is a very long return type to type out. And also it's one that would essentially break a bunch of code as soon as you decide to change it up a little bit. So it's much nicer to say, hey, I'm just going to give you a publisher, and you shouldn't care whether I got there by mapping, flat mapping, compact mapping, reducing, mixing, zipping, whatever you can do. All you need to know is that you're going to get this kind of an object, and this is the failure type. What happens on the inside should be completely irrelevant to anybody using this publisher. So erasing to any publisher is not something that gives you any functionality. So it's not like you should do that if you don't care about the return type. It's only if you want to return a publisher from someplace to make it look nice and to make it readable, and so you can type it without spending all day trying to remember what the correct return type would be. So there's also Marius's question about stack traces in Combine. Now, I haven't spent a ton of time looking at Combine stack traces, luckily. However, the ones that I have seen are only marginally better than those that you would get in RX. So you will typically be able to figure out which operator, for example, failed, because all operators in Combine are actually publishers. So you'll be able to see that you were inside of a flat map publisher or that you were inside of a zip publisher, for example. So it's slightly nicer, but it's still not great. It's still a bit of a puzzle. Luckily, you can, of course, use operator like print, which also exists in RX, to sort of get some insight into where you are. But yeah, they're not the best, unfortunately. And I think with anything that's this functional and closure based, and not stacking all these function calls, I think you won't be able to get something that's super easy to navigate anytime soon. So that's kind of unfortunate. So then there is Jerry's question, who says, combine plus operations. How would this all look if I would use operations with combine? And that would kind of be using RX and combine at the same time, right? Because operations already wrap asynchronous work. It schedules the work on a queue. Now, of course, what you can do is create a future that lives inside of an operation and then fulfill the future with the result of your operation when the operation is done. So you can then subscribe to the result of this operation. That would work. However, it does not provide any extensions for operation like it does for URL session. And I think that's pretty much for the reason that operations and combine solve very similar problems. So that's sort of where I'm at on that. It would maybe be nice to get the output of an operation, but operations don't necessarily produce output like a URL session would. So it wouldn't make sense for all operations to have a combine extension. Now here's a fun one from Axel. He read my book, but it's still not 100% clear. Probably need to produce more code. Yes, practice makes perfect, Axel. Even though this stuff doesn't have to be extremely hard, it's still stuff that you need to practice, stuff that you need to see often, stuff that you need to, learn by doing. There are some fundamental building blocks, like you have a publisher that emits something and you can transform the output using something like map. That is really the easiest way to explain it. However, for it to make sense, you're going to have to practice. So a follow-up question on the one I did before about erase to any publisher. Yes, it's entirely only needed because Swift is strongly typed. If you would not have something strongly typed, you would probably not have to use it because it wouldn't care right? It would just do whatever that's needed. So yeah, in JavaScript, I think you would not erase to any publisher because JavaScript doesn't have types. Another question, does Combine also have all those confusing different types of publishers like RX Swift? No, it does not. Axel says Marius, yes. Unfortunately, it does not, or fortunately, actually, it does not have all of these confusing different publishers. Combine has a publisher, which will just publish events. It has subject, which allows you to publish events on demand. And then there's future, which is really also just a fancy publisher that you get to decide what the work is that it performs. That's really the three main ones, and then you have a few specific subjects. However, it's not like you have a single, a maybe, whatever else RX has. It's much simpler than that, which is very nice. So Paula asks, is this all SwiftUI specific? No, it is not. SwiftUI is indeed, like Axel says, very helpful. Thank you. SwiftUI is built very much on top of Combine. However, Combine can really be used for anything where you have asynchronous work and want to subscribe to the output of that work. So it's also very useful in UIKit or in really, even in applications like that don't have a UI. For example, a SDK, for example, you could use Combine in there as well, and it would be very useful there too. So yeah, Combine is really useful for, like Andrew also says in the chat, it's useful to architect anything, also without SwiftUI. And there's one last thing about an instruments tool called Timeline Combine, which is very useful. It indeed visualizes how your publisher emits values, how they are generated, when they are emitted. So if you really want advanced insight into what your publishers are doing, I can highly recommend Timeline and then specifically Timeline Combine. There are also flavors for Timeline that work with, I believe, operations and even RX Swift. So you can really do anything with it. So yeah, stuff like set timer, dispatch queue, main async. You're still going to have to dispatch to the main queue if you use Combine, because, well, background work will need to be dispatched to the main queue. However, you can use Combine's very convenient receive on operator to go to the main queue immediately when you subscribe, so you don't have to do the dispatch queue main async thing. That will be done automatically. If you're using Combine to update a UI, would you need frequent dispatch queue main async, right? Well, that question came in as I was answering it, and we have a slight delay. So no, Andrew, you can use receive on dispatch queue.main, and all the code in there will automatically be dispatched to the main queue asynchronously. So it's all in your sync, already there, so you don't need to do that all over the place. It looks slightly nicer, in my opinion. And I think that is all the questions that we have in the chat right now. Let's give it a few more seconds to see if anything comes up. Yeah, I think we're going to leave it at that. Okay, wait, one more question just came in. Did you experience that Combine is not convenient to use in any UIKit area? Not per se, no. If you want to use Combine to respond to things like button taps or changing slider values or that kind of stuff, Combine is not very convenient because it doesn't have support for that built in. So you would need to build a publisher around that. However, other than that, I find Combine to be very useful. For example, if you would have an MVVM app and your view model fetches data from core data from the network or wherever, you can have your view model have a publisher that will emit a value when this work is done, or you can return on any publisher from that function and subscribe to that to get the result. So it's actually very convenient in any area, in my opinion. It just depends on like how many magic do you want from the framework, because RX of course has these tight integrations with UIKit that you don't get with Combine, but in my opinion, that is not a big deal. It's only a small section of what you could do with something like combine. And I think that really was the last question. So yeah, thank you all for listening to this talk. I see that a bunch of people enjoyed it. So that is fantastic. That makes me very happy. And yeah, if you have any further questions, feel free to drop them in the chat or on Slack or wherever you can find me. And I will happily answer those. So thanks again, and have a fantastic evening, everybody.